Hello, I have this repository for the Speak programming language, still in active development, and I wanted to create a playground much like Golang. Golang's playground, it's playground. But what I wanted to aim for is something to what inspired me to start this project in the first place. Uh, it's from Linus Lee. It's a project by Linus Lee. It's called Ink. It's a programming language. And if I check at the website, uh, um, yes, we have an input and an output section for the Ink language. This is what I want to aim for, but at the moment, the language is not really that mature, and it's actually my final project. So what I'd like to do instead would be, let me check, actually, oak. So this guy also has another programming language called Oak. He's a smart dude. Okay, where is it? Okay, here we have. Not sure if it's the official. Try Oak, okay. Linux other platforms. I'm not sure where he puts the he puts his obviously it's not there. I'm not sure where he puts the playground for the Oak language, but it's something that I saw in his talk for. He has a talk, Oak, Linus Lee. So there's a look I'm going for. There's a place where he illustrates.
In our source code has been singled
okay,
out.
here we have it. It visualizes the token stream and the syntax tree for uh, for for an awk program, basically.
And the
Somewhere along here we have
the list.
That was the syntax tree.
There, this is at the end here.
Okay. So basically, what I'm going for is what we have here. We have an input and an output section, but also as much as we have an output section, I should have a way to visualize the token stream and also the syntax tree for whatever input that is here.
Structure of packet work is going to be
something similar to this. I cannot try to copy it, but that's okay. So what I wanted to use for that is it's a Rust sort of framework. Yes, it's a framework for front-end applications. There's a couple where you can get started with writing I've done this before, but it's been a while, so maybe we can have this is the aim of the video, creating the playground using you and aiming for something that's more of like this and this. So I think the first thing we can do is maybe create a UX create a UX for a playground. I'll be using my iPad and GoodNotes. Blank paper, create. So I prefer the input to be more of like this, but also I'd like to have the numbers for each line. That way, if there's an error somewhere and I'm showing a number, a row number, it's easier. It's easier to know where the issue is. Okay. So you can have speak, playground, an about section maybe, not sure. Okay, that's not really necessary. Yeah, maybe not necessary. Okay, then we have our input section. I'm going to upload this later on. Okay, it's numbered 1, 2, print hello world. Then we have a run button, obviously. Then on from here we can have the token stream and the syntax tree. So the token stream, syntax tree. By default they're shown. Where are we going to have the output? This is what can you guys see? Not sure. Okay, I'll set it up, but maybe much later. We have a run button here, then we have an output section. Outputs. Okay, right. So if I go back to the project, it's one of the issues I had created earlier. It's part of the enhancement. So what we'll do, I have the project open in VS Code. What we'll do, we'll create a branch called www. Clear. Okay. So the next thing we're going to do, so I'm not really sure how to compartmentalize the different builds there might be this is the build for the interpreter, then there'll be another build for the what do you call it, for the playground. I can use submodules. It's called git submodules. This is where you can have a git repository, a subdirectory of another git repository. I think this would be better. That way you can wholly concentrate on the playground bit. So instead of creating another branch for Speak, what we'll do, we can leave this branch here and then link the playground later. So let me close this. Let me open up. Okay, documents, projects, Speak mkdir. I was learning Haskell. Speak playground. Yes. Actually, that's not how we create Rust projects. So I'll just remove that. Fast recursive Speak. Let me see how we create a new project. Okay, target, we must install our WebAssembly target. Let's make sure that's installed. Okay, well, that installs. Let's check out what else. I did an update recently, so I should be okay. Okay, then we'll install trunk is recommended tool. Okay, let's do that. Well, that installs. Let's see. There are other options on the trunk. You might want to try one of these. Let's go with the recommended tool. The next steps. Okay. Minimal templates. I don't think we'll need a template. We can just start with a hello world example. So you app, you info, blah 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 blah. Okay. Cargo new Speak playground. Is the build stuck? Um, come on. Okay, that bit is done. So the next step would be to create a project file, project folder, cargo new, what do we call it? Quick playground. Okay, get into the Speak playground, or rather we open VS Code to that directory. So the first thing we should do is set up the U dependencies. So U app, edition, blah blah blah. Then we have U version. Let me remove this. Okay. Let me do cargo fetch. Okay. You only need feature CSR. If you're building an application, you should enable the renderer and all client-side rendering related code. If you're making a library, do not enable these features. It will pull in client-side rendering logic into the server-side rendering bundle. Okay, we're not creating a library, so we're okay. Dev dependencies. Okay. You need to generate a template which sets up a root component called app, which renders a button that updates its value and clicked. Replace the contents of the following code. Since it's basically what do I call it? Okay, let's first make sure that our hello world example runs. So we just do cargo run. Okay. This bit is not actually necessary, it's part of the U version, I'm guessing, but let's just make sure everything is okay. Since it's our first time, relatively for me, it feels like the first time I've used U before, since it's a long time since using U. Let's use the example code just to make sure you understand what's going on. Okay, we should create an index.html at the root of your app. I should copy this in main.rs. Okay, let's go on to do that after. Okay, we have a successful hello world. So let me take that, copy it in there, then create an index.html and copy this. Is it within the src? Root directory of your app. Root directory. Okay, so it's just here. No, outside. HTML. Paste. View web application. Trunks have. Okay. So where is it being served at? Not really sure. Okay, I've built the app, but Fetching, cargo processing, downloading. Okay, maybe there's something I'm missing here. There's something I'm missing. Oh, here. Oh, it was still building. Okay. You up. Okay, this logo for traffic. I still have Docker running, I guess. Or maybe it's no, I don't have Docker running. This is maybe it's cached by the browser, so that's why you see it here. But it's not supposed to be a logo here for this example. Okay, so the example does work. Okay, so let's move on. The next step would be okay, I don't think we really need that. So we have a function component which renders HTML as its output. I'm assuming you renderize or struct. It's a struct that takes a generic I wouldn't call it an argument, but it's like a variation of renderer that must implement base component, and a variation of comp that implements base component and static. It's static. I think static, it means it has a static lifetime. I have ChatGPT here. Let me delete that. Okay. It's always good to understand explain as a generic parameter to the generic parameter. Okay, let me mention that it's in Rust. Yes, it has a static lifetime guaranteed to last for the entire duration of the program. Okay, I think that's enough. So for what we're going for, I think the first thing we should create is okay. I think we should have the input tab, input section, do I call it a section? How do I call it? Naming is always a pain point in programming. I'll just call it speak input, or let me just settle with the input. It transverse HTML. I'm not really a fan of I like Copilot. I usually use it for boilerplate, but for today, so I can say input represents doing user output. HTML to output presents the playground output. If any. Then have the token stream. Okay. So it's alright. HTML. Finally, syntax tree. So in Rust for function names, we do not actually use camel case, we use snake case. It is a function component. Okay, I know it's a function component, but how do we actually use chain multi-function components? This is an assumption I made. Maybe I'll have to refactor later, but I should actually get to understand how, if I need to annotate each of my functions with this macro. I could ask GPT explain let me just function component. They could do a search instead. Function components. Simplified version of normal components like consist. On its own, that would be quite limiting because you can only create pure components, but that's where hooks come in. Hooks allow function components to maintain their own internal state and use other use features, and will implement the component trait. Okay, under the hood there are two parts on how you implement function components. Provide a trait which is analogous to the component trait except that it only has a single method. Okay, so basically a function component can receive props and returns HTML. Right. So I'll say that for our inputs, I'm sure we should have what's it called? HTML user input. What's it called? HTML user input. It's called a form. Yes, sorry. Let me see forms. Form, HTML form. Okay, let me just search instead then. View HTML form. Oh no, that's not it. Formula. Okay. We'll definitely have to use this one because we need to capture the input. So HTML form capture the input. Okay, the next thing, we should have a style that numbers, rows, yeah, like 1 2 3 blah blah blah. What else do we need? Within the input we have a button, not form button, that says run. Okay, so that's all for the input. The next thing, okay, I was thinking of doing WASM build, WASM interpreter build, bundled with playground. Yeah, I'll do this. So the next thing for the output, WASM interpreter, speak WASM interpreter, speak WASM interpreter provides output, if any, and then render output. Okay, the interpreter provides token stream, render token stream. Provides the syntax tree. Syntax tree. Okay, so I'll stop the video at here. In the next bit, I'll try to create a placeholder input, placeholder output, and placeholder token stream and syntax tree, just to get the UI right. Then I'll add the actual functionality later, and that will give me time to do a bit more research on the form, how I'll be creating the form using Vue and styling the form with the form input with column row numbers. Then also in a follow-up video, we'll create a WASM interpreter for speak language. I'll catch you guys on the next one.